plane. So the last topic was what? Motion in a straight line. Now motion in a plane. Okay, that means motion in a 2 dimension. Okay, so in this chapter you are going to study about lot of things which you can experience in your day-to-day life. Okay, so why some people hit the six easily in your cricket. Okay, so why Gale six will go far away, why some people cannot cross the border if they lift the ball. Okay, so or else why the AB Villiers can easily hit the six. All these things you can study here. Okay, it is not depend on the energy. Some people are having very much energy, they are physically fit but they can't hit the six properly. Okay, some people are very much lean but they can easily hit the six. What is the reason? Is the length of the six depends on your energy or your physical fitness, or it depends on something else, or is there any physics in that? Okay, so obviously there is some physics in projecting the ball, in hitting the six. Okay, so if you give the proper angle to the ball with your bat, so what will happen? It can easily go to the six. No need to put the lot of energy or something. Okay, so all those things we will study in this chapter. You will enjoy a lot, but before that, in this chapter we should know about the vectors. Okay, so obviously chapter name is what? Motion in a straight line. We are going to study about the motion of the not a motion straight line, motion in a plane. Okay, so we are going to study about the motion of something which can move in 2 directions. Okay, but before going for that end, we should know about everything about the vectors, what exactly vector is, how we can add the vectors, how we can subtract the vectors. All those things we have to study first. So that is why so in our competitive exams we will divide this chapter into 2 parts. That is what one we will take separately vectors, then we can go with the projectile motion or motion in a plane. Okay, so similarly in this chapter I am going to start with the vectors. Okay, so don't think that in your exam vector chapter is not there. Vector is there in your motion in a plane, but I will give the name vectors only. Okay, so after finishing vector I can take this heading. So we'll start without delaying. So what we are going to start? We are going to start with the motion in a plane. Within that we are starting vectors. Okay, so for few classes we are going to study about the vectors. Okay, so we'll start with vectors. So vectors, we are going to study about the vectors now, but before that we should know something called what is physical quantity. What is physical quantity? So what is the physical quantity? So many times we can use vector is a physical quantity or scalar is a physical quantity. Then first we should know what exactly physical quantity is. So how we can you must have studied also what is physical quantity or something. So I can directly give you what exactly physical quantity is. Physical quantity is nothing but any quantity which can be measured. Any quantity which can be measured is called, or which can be measurable. Okay, the any quantity which can be measured is called what is called as physical quantity. Is called as physical quantity. Okay, so anything which can be measured or which can be measurable, any quantity in the physics or in the world which can be measurable, so that quantity is called as what? Physical quantity. Okay, so for example, suppose mass you can measure. So mass you can measure. Okay, so 10 kg, 50 kg, 100 kg, so 200 kg, whatever. So mass you can be measured. Time also you can measure. Because 1 o'clock or 60 seconds, 30 seconds or 35 seconds, 2 o'clock, 3 hours, 4 hours, like that you can measure the time also. Okay, so temperature, Temperature. So temperature you can measure, and measuring temperature is very important. Okay. So nowadays, so temperature is like taking very major role. If temperature is 36, okay. If it is crossing 39 or 40, you have to go for what? You have to go for COVID test. Okay. So that is what the temperature is measured on. So we have to measure the temperature. Okay. So these kind of things which can be measured is called as what, or they are called as what? They are called as the physical quantities. Okay. So if you want more examples, you can take the speed, or you can take the velocity. All these things are all these things are you are going to what? Measure. Then you may ask me, is there any quantity which cannot measure in this world? Obviously, you can think there are some quantities which you cannot be measured. Okay. So there are the quantities. There are quantities which cannot measure, which cannot be measurable. Okay. Which cannot be measured. Okay. So then what are those quantities? For example, your feelings. You cannot say today I am, say, 10 kg of happiness. It is not possible. You cannot say today I am, say, 100 kilometer of happiness. No, you cannot measure your happiness. Simply you can say I am very happy today. Simply you can say I am very, very, very happy today. You cannot say I am 1 quintal of happy today. So it is not possible, because you cannot measure how much you are happy. You can simply say very happy. What is the value of that very? We are just giving a word to express I am little more. Okay. So that is what if you take the sadness. So today I am 0.01 millimeter sadness. It is not like that. You cannot say like that. Okay. So what you can say, I am very sad. Okay. So beautiful. Rose is some 10 kg beautiful than some other flower. You cannot say like that. You can maximum say, yes, rose is very beautiful flower. Okay. You can use just beauty or very beauty. You cannot give some number for that one. Okay. So these are the quantities which you cannot measure. Okay. So what are those? There are the quantities which cannot be measured. So what are those? Your happiness, or your sadness, or your beauty, whatever. Okay. So these are the some quantities which you cannot measure. So the quantities which can be measured, they are called as what? They are called as the physical quantities. Okay. So once you understand what exactly physical quantity, so then you have to measure the physical quantity. So you have to measure physical quantity. Okay. So if you want to measure, when you start measuring the physical quantities, okay, so what will happen? There are some quantities. Suppose if you take some rice, okay. If you take some rice, so what will happen? You will say rice is of 5 kg. Okay, rice is of 5 kg. If you take a time, so you can say it is say some 6 p.m. Okay, whatever. So just you are saying some magnitude. Okay. So how much it is there? Rice 5 kg is there. That is what we call it as the magnitude. How much amount, how much quantity we are having. That is what the magnitude. Okay. So if you say this much, if I ask you how much quantity of rice is there, you will say 5 kg. I will be happy with that one. It is enough. Okay. So if I take what's the time? Okay, it's 6 p.m. If you say that much, it's enough. There are no more questions from my side to ask you. Okay. So instead of that one, if I ask you, where is bus stop? Where is bus stop? Okay. So if I ask you where is bus stop, if you say just 100 meter from here, if you say just 100 meter from here, am I happy for that one? No. I have one more question to ask you. If you say just 5 kg, I will be happy. If you say 100 meter from here, I will not be happy, because in which direction I have to go 100 meter. Suppose this is the circle. So there are 4 paths are there. So 4 routes are there. And you are standing here, I come here, and I will ask you, where is bus stop? Then you will say 100 meter. 100 meter, I have to go on this side, or this side, or this side. So what is required here? Direction, or mentioning direction is also required. So what you have to say? You have to say just 100 meter from here in the north direction, or sorry, in the north direction, or in the south direction. Okay. So in north direction, in south direction. Okay. So when you say 100 meter from here in north, then I will be okay. I will be happy. But simply if you say 100 meter, I will not be happy. Okay. So that means in measuring, there are some quantities which you cannot simply measure the magnitude. Only you can measure the what? Magnitude. So measuring magnitude is enough. There are some quantities for that. If you measure the magnitude, how much quantity is enough. But there are some quantities, if you measure only magnitude, it is not enough. Along with magnitude, you have to tell about what? You have to tell about direction also. Okay. So there are physical quantities which can measure only magnitude. There are some physical quantities for which we have to measure both magnitude and direction. Okay. So that is why. Suppose if you go to the some marketing or something. So if there is the packet of some rice or something, whatever. So on that they will write, say, some 25 kg. So some rice is there, so they have written 25 kg. You will be happy for that one. You did not ask 25 kg of rice in which direction. So shopkeeper will slap you. Rice what direction? Okay. So but instead of that one, suppose you are traveling on the highway and there is some board. Okay. So there is some board. So on that board, what they have written is, they used to write, say some Bangalore, then some Mangalore, some Delhi. Okay. So if they write only this much, the people will laugh you. So what? The Bangalore, if they is some 600 kilometers, say it is some 400 kilometers. This is, say, some 2005 kilometers. If they write only this much, people will not be happy. People will laugh for what they are saying. We know that one. So along with this, what they will give, they will say, they will give direction. Okay, this you go and move in the right direction. So if this can be in this direction. Okay, so this can be in this direction. So there will be different routes for that. Okay. So these directions are required to tell the displacement or some ways or some displacements. Okay. So this is what here what is required. Here it is required both magnitude. 600 is what? 600 is magnitude, means quantity. That 600 is what it is, a magnitude. Okay. Then what about this one? This will show you what direction. Okay. So this will show you what direction. If you mention only 600 kilometers without direction, there is no meaning. If you give only direction without telling about the magnitude, then also there is no meaning. Okay. So that is why there are some quantities for that which you have to tell both magnitude and direction. Okay. So that is why based on this I am going to divide physical quantities into two parts. Okay. So here what will have measurement will complete only from magnitude. Okay. So magnitude can completes measurement. Okay. Magnitude can complete the measurement, but here magnitude plus direction. Magnitude plus direction can complete. Magnitude plus direction can complete the what? Measurement. Okay. So here if you measure only magnitude over their magnitude with direction is over. Okay, so that is why, so I will divide physical quantities into two parts. So there are physical quantities which have only magnitude, those are called as what? Those are called as scalars. Remember, there are some physical quantities which have both direction and magnitude. So they are called as what? They are called as vectors. I hope you are understanding. Now you only can define yourself what is scalar. Scalar is what? The physical quantity which has only magnitude. Obviously, all are physical quantities only. Either it is vector or scalar. They all will come under what? They all will come under physical quantities because they are measurable. Okay. So what are the scalars? They are the physical quantities which have only magnitude. Vectors, physical quantities which have only direction. Okay, so this is what the two types of measured physical quantities. One is scalar, another is vector. Okay, so physical quantities will be of two types. One is scalar, another is what? Another is vector. Okay, so these are how we can divide the physical quantities. One is scalar and another is vectors. Okay, so we will define scalars and vectors separately. So scalars. So how we can define it? Any physical quantity, the physical quantity which has only magnitude is called, or you can add something also, but not direction. Is called what is called scalar. Okay, so example for scalar quantities. So can you write mass? Yes, mass is a scalar quantity. How much quantity of mass is it? So already you know time is scalar quantity. You know temperature is scalar quantity. Today temperature is say 27 degrees Celsius. That much is enough. In which direction? Not required. Okay. So time now it is say 10 o'clock. That much enough. 10 o'clock in towards Bangalore, towards Belgaum, not required. Okay. So mass, how much of mass is there? I am 52 kg in south direction. No, you can stand in south direction or in north direction. Your weight will be what? Your weight will be 52. It will not change with the direction. Okay. So these are the what? Those kind of things are called as what? Scalars. Okay. Similarly, I will define vectors also. Okay. So vectors. So how we can define the vectors? The physical quantity which has both magnitude and direction. Both magnitude and direction is called vector. Okay, is called vector. Example here, very important example. Velocity. So I ride a bike with a speed of say 100 km per hour. In which direction you ride? Okay, so that is very important. In north direction towards Belgaum. I went to Belgaum with a speed of say 100 km per hour. That is enough. Simply I go with a speed of 100 km per hour means what? There is no meaning. That means you may be rounding here only. Okay. So direction is required. Acceleration, very important. Direction is for acceleration. So you are accelerating towards what? Okay. So because velocity is a vector, means obviously acceleration is what? Rate of change of velocity. So that is also going to be what? That is also going to be a vector. Very important, force. Very important, force. Force is going to be what? Force is going to be a vector, because direction is required. Suppose there is a vehicle standing. Okay. So suppose it is having some problem. If a driver asks you to push it, okay, if he did not say push it in forward direction or in reverse direction, so you will come and start pushing in this direction, okay, you will come and start pushing in this direction. What will happen? It absolutely going wrong. So whatever work you've done, it is going to be waste. Okay, so that is why if a driver mention, so please push it in forward direction, so then what will happen? You will go in behind, so you will push in this direction. Okay, unless mentioning the direction, if you apply the force, there is no meaning for that force. That work is going to be waste. Okay, so that is why force should have the both. So how much force you are applying? Okay, 5 Newton of force you are applying. So 5 Newton of force in which direction? In forward direction. Here 2 Newton of force in which direction? In backward direction. So all direction and both magnitudes are what? Magnitude are required here. So these are the examples for the what your vectors, and these are the examples for the what? Scalars. Okay. You may ask me, sir, what about length? Length is scalar or vector? Okay. So simple. If suppose I am having some duster or something. So if I ask what is its length, so then you will take a scale and measure. Okay, some 12 centimeter. So I did not ask in which direction, because simply you will know length means you have to measure in this direction only. Okay. So if I hold in this direction, will the length will get changed? It will not get changed. Now also it is 12 centimeter only. Here also it will have 12 centimeter only. So no need to tell the direction. Okay. If you say 12 centimeter, I will understand. So length of a duster is what? 12 centimeter. Direction is not required. Okay. So length will be what? Length will come in what? It will come in scalar. Okay. So but there will be confused regarding the distance and the displacement. Okay. Suppose you are having a here and at some distance, so there is a point B. Okay, so one person will go in this direction and will come here. Okay, this is what actual path covered, that is what the distance. What about this one? This is a straight distance from A to B. So this is what? This is displacement. Okay. So now you can easily understand which is a scalar, which is vector. See here, distance is what? Actual path. By changing your direction, that will not alter the what? Distance. So distance you have to measure wherever you can go. Okay. So if you say distance, I will not ask you in which direction, because I will understand it may be in many directions. Okay. But if you want to tell about the displacement, the definition of displacement only tells you what it is. It is the straight distance from initial to final position. Okay, so then that is a shorthand distance. You have to measure in the straight direction. So it has some direction. You cannot measure what your displacement in this direction and then this direction. It is not possible. Okay, so displacement means only what? It is a straight direction or straight distance from the initial to the final position. Okay, so that is why your displacement is going to be what? Your displacement is going to be a vector. Okay, so I will take displacement as a vector. Displacement will be a vector, and what about distance? Distance is a scale. Okay, but if you think in another way, both are lengths only. Okay, so that is a different thing. So I hope you understood what is the displacement and distance. So now. So in this chapter, what is required for us? Required for us is vectors. So we have to concentrate on vectors. Why we have to concentrate on vectors? So I will tell you. Suppose you are having some 5 kg of rice here, and you are having some 2 kg of rice here, or anything. So total what you will get? You will get some 7 kg of rice. Okay. Now Both are what? Scalar. This is what? Both are what? Scalar. No problem, you can as usual add it. So you are having 5 kg of rice, and you have taken out 2 kg of rice from that one. How much remain? 3 kg. Okay, so that is not a problem. You can change direction or something. This value will not alter. Okay, instead of this one, I am applying 5 Newton of force here and same 2 Newton of force in this direction. So how much you will get? You will get 7 Newton of force. Okay. If I change the direction of rice, this value will not change. Again, it is 5 plus 2, 7 only. But if I change the direction here, suppose 5 Newton I will apply from this side and 2 Newton I will apply from this side. So now what is the net force on this one? What is the net force on this one? 5, somebody is pushing with 5 Newton in this direction, somebody pushing from 2 Newton from that direction. So what is the net? Net will be 3. Getting or not? So what will happen? It will go in this direction for little distance. Here it was moving for a long distance. Okay. So what has happened here? Here it will become 5 minus 2. Only net result will what? 3 Newton. So in terms of vector, in vectors, what will happen? If you change the direction, your addition, subtraction or some multiplication is gone changing. But here it is a normal algebra. Scalars you can use simple normal algebra, but you cannot use normal algebra in case of vectors. So that is why I am going to concentrate on the vectors. So we have to concentrate on vectors. So that is why we are going to take the heading as a vectors. Okay. Now we can start with vectors. What exactly vector? How we can add, subtract, multiply, all those things. Okay. So we'll see.